Helps if I record that. That is delicious. So when we are looking at inequalities, we need to make sure that we pay attention as to whether or not we get to include it, like this example where I get to include it, so I use a bracket, or this example in which I use a bracket. And that's because right here I have the inclusive. If I don't have it as this example here, where I don't have the inclusive, then I'm going to use a parenthesis. So non-inclusives mean parentheses, inclusives mean brackets. Got any questions for me? Okay, so we're going to talk about two different kinds of inequalities. We have a compound inequality, and then we also have the inequalities in which there's an or, and we don't get to include a middle piece. So a compound inequality is such that you can take out the middle piece and it'll still hold true. The direction of the inequality doesn't matter. What I mean by that is, this example is I have 3 is less than or equal to x minus 1, which is less than 7. Now, if I take out this middle piece, then that still has to hold true. So 3 is still less than 7, so that's good. And then if I take and look at this example here, if I take out this middle piece, 24 is greater than 12. So the inequality direction does not matter as long as they're all going in the same direction. And I've got to be able to pull out this middle piece and have these two ends still hold true. 24 is greater than or equal to 12. So it doesn't matter if I have the inequalities going greater than or if I have my inequalities going less than. As long as I pull out that middle piece and it still holds true, then we have a compound inequality that will work. Now, we have two options when we solve for compound inequalities. Option 1, I'm going to go back up here, and I have 3 is less than or equal to x minus 1, which is less than 7. My first option is I can break these apart with an and statement. So I would write 3 is less than or equal to x minus 1, and I use and when I'm using a compound inequality in which I have a sandwich. X minus 1 is less than 7. And I work each one individually, and then I bring it back together. My other option is I just do it in one piece. Because it's a compound inequality, as long as I do the same thing in each piece, the left piece, the middle piece, and the right piece, then we're okay. So I'm going to add 1 here, and don't forget to add 1 here. So if I do it in one piece, I can do that, or I can break it apart. So I know that a number of you have seen these and done these before in your previous math courses, and I really want you to do whatever you're comfortable with. So if you're comfortable with breaking these apart, please, by all means, continue to break them apart. If you're like, this is the first time I've seen it, then I want you to do the one that makes sense. I'm going to do this as a single compound inequality. So I'm going to add 1 everywhere, and so I end up with 4 is less than or equal to x, which is less than 7. And then I can do it basically in this particular case in one step. Now, if I wanted in interval notation and set builder, my set builder would look like this. So curly bracket x, 4 is less than or equal to x, which is less than 7. My interval notation would be inclusive on 4 and non-inclusive on 7. So there's my example. Now I want you all to do A. With A, don't forget when you are doing a division or a multiplication by a negative number, all of your inequalities do change direction. And Ashton, you had a question? Oh, yes, thank you. Yeah, I was just waiting to see if everyone was awake, so that should be an 8. I was just seeing if you all paying attention to me. Ha, 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 ha. So those are 8. Thank you. All right, so go ahead and do A, please, and they'll give me an opportunity to do attendance. And then your set builder or your interval notation would be a parenthesis at -4, comma, and then -3 will have an inclusive. Oh, Thomas, don't worry. Look at me. I did 1 plus 7, and I got still 7, so it's all good. It's all good. All right. So let's take a look at this one. So go ahead and do this one, please. So this is B. Give B a go. With B, you have 2 choices. Option A is you divide everything by 2 right out of the gate. Option B is you distribute the 2 and then work it by adding 3 to both sides or whatever it is that you need to do. So however you want to work it, I'll give you a couple of minutes to do that. Someday I'm going to have that recording right out of the gate and I don't have to go back, but not today, I guess. Today is not that day. So option A is to divide everything by 2. And then I end up with 3 is less than or equal, or less than x minus 3, which is less than or equal to 6. And then I'm going to add 3 everywhere. And I don't have to change the signs on this one because I'm not multiplying or dividing by a negative number. 2 here was positive to begin with, and because it's positive, I don't have to change the direction of my inequality, unlike my previous one. So it's only when I have to multiply or divide by a negative number is when I will have an inequality change directions. This one I'm just adding. Now, once I've divided by a positive 2, which means my inequality doesn't change, I'm going to add 3 everywhere because I really want to isolate that x. And so I end up with 6 with a parenthesis to 9 with a bracket. And then with my interval notation, I'm going to be lazy here and just do this. Because I can. I like interval notation because it allows me to be a little lazier. Now, if you did it like this, you should still have got the same answer. So if you said, I'm going to wait because I want to possibly avoid fractions. If I want to possibly avoid fractions, I'm going to distribute that 2 through. So I have 2x minus 6 is less than 12. So then I'm going to go ahead and add 6 everywhere. So I'm going to add 6 here and here and here. So I'm going to get 12 is less than 2x, which is less than or equal to 18. And then I divide by that 2. It's still positive. So I'm still going to get the same answer. 6 is less than x, which is less than or equal to 9. So whether you decided right out of the gate, you're going to get rid of that 2, or if you decided to distribute the 2 because you were concerned about getting fractions, it doesn't matter. You're going to get the same answer. Is there any questions on that? Any questions at all? Okay, so let's go on when we have absolute values. Now, with an absolute value, when we're talking about absolute value, it is a distance to 0. So because it's an absolute value and it is a distance to 0, if I were asked to find the absolute value of x is equal to, say, 7, then I would have 7, the distance from positive 7 to 0 is a distance of 7. So that is a distance of 7. And then, of course, I would also get negative 7 because it also has a distance of 7. So if I have the absolute value is equal to 7, then my solution is going to be x is equal to positive and negative 7. Because both of those are going to give me a distance to 0. Now, if I am asked to find the, let me do this in blue. If I'm asked to find the absolute value of x is less than or equal to 7, then I want any numbers so that its distance from that number to 0 is 7 or less. So when I have an equal sign, I expect an answer or 2. I actually could get 0 answers, but I expect something to either have the no solution or expect it to be x is equal to a single number, x is equal to 2 numbers. But when I have an inequality, then I'm asked for a solution of numbers, a set of numbers, and the solution to an inequality absolute value would be from negative 7 is less than or equal to x. Negative 7 is less than or equal to x, which is less than or equal to 7. So this is going to be an interval of numbers, so it goes from negative 7 to 7. So if I have something that says I want the absolute value is less than or equal to, I'm going to sandwich my numbers, and because it's an and this has to happen. Now, still using my example with 7 here, if, I'm going to do this now in red, if my inequality would have been the absolute value of x is greater than or equal to 7, that means I want all the numbers whose distance is larger than 7. So the larger than means I want all the stuff on this side of 7, and I want all the stuff on this side of negative 7, because all of those numbers will have numbers that are larger than 7, and unfortunately I can't do a compound inequality. When it's in this form, notice I can do a compound inequality. If it is less than or equal to, I can compound it. I can put the positive and the negative, negative on the left, positive on the right, and I'm cool. But if I am in this form, I don't get to do a compound inequality, because remember, with compound inequalities, it has to hold true. I can't do this. -7 is greater than or equal to x, which is greater than or equal to 7. Because like I said before, I've got to be able to pull out that middle piece and still have it hold true. -7 is not larger than 7. So when you have a greater than or equal to, you have to break it apart with the or statement. Right up here, this or statement. So what I typically do is I say -7 and 7. I still break it up that way, but I have x has to be greater than 7. But here, I have to have x has to be less than. But I don't do a compound inequality. I cannot bring these together. I'm not allowed to bring these together. So I still kind of set it up like a compound inequality, but I'm not going to join them together. And so this ensures that I am on the left side of -7, and this ensures I am on the right side of +7. So with all of that said, is there any questions before I have you do these examples? Let me do one more example, then I'll have you do these. And the example I'm going to do is going to be similar to B there. I'm going to do an equality, and I'm going to make sure an absolute value inequality, but there's a couple of things that have to happen for me to break this apart. So if I would have had, say, -3 x plus 1, the absolute value, minus 2 is greater than or equal to 5. Then the first thing I have to do is I need to isolate my absolute value. I can't do what I did here until I've got my absolute value isolated. So if I have any number in front of it, I do need to get rid of the number in front of it after, of course, I have moved that 5. In this example that I'm going to be doing, I don't have to worry about this number in front because there isn't one. So I'm going to move the 2 to the other side, so I have the absolute value, -3x plus 1, is greater than or equal to 7. And once I have done that, then I can go ahead and break it apart. Just like I did before, I have a -7 and the 7. I know that -3x plus 1 has to be greater than or equal to it. But I also know that 3x minus 1 has to be less than or equal to it. I cannot do this as a compound inequality. I do have to do this separately because of this. I have to write the word or between them. This or this has to happen. So now I'm going to go ahead and continue with this and subtract 1 from both sides, and I get -8 is greater than or equal to -3x. Notice I have to work one side at a time. When I divide by a negative, then I'm going to end up with 8 positive 8/3 is less than or equal to x. I'm going to go work this other one, so I have -1 and -1. -3x is greater than or equal to 6. Divide by a -3. And I have x, don't forget to change the inequality, x is less than or equal to -2. Somewhere I messed up on my inequality. Oh, let me see. X has to be greater than. Changed where? Oh, no. Nope, I'm good. Had a moment of dyslexia. Okay, so if I were to put this on a number line, here is the number -2, and so we have this. And here is the number 8/3, and we have this. So this goes here, this goes here. So my solution on this is -infinity to -2 inclusive, union between 8/3 and infinity. So that is my final answer. So if you all could do A, B, and C, please. And I'll leave that up there for you. So With A and C, once I have my absolute value isolated, I can sandwich because it is a less than, or if it's a less than or equal to, I can sandwich. So for A or C, then what I can do is I can go -2 is less than y, which is less than 2. If I were asked to write this in set builder notation, I would just have to do this curly bracket, and sorry, it should be y there, not x, because that's the variable I'm using, y, such that y is greater than -2 but less than 2, and then interval notation should be parentheses. So I'm going to jump down to C because it's going to be similar. For C to happen with the sandwich, then I first have to subtract 5 from both sides. So 2 times the absolute value of x is less than or equal to, and that's 2. Now I'm going to divide by a 2, and because it's positive, I don't have to worry about changing the direction of my inequality. Because until I isolate my absolute value, or whatever's inside of my absolute value, I can't actually take off the absolute values and do the sandwich, or the or statement. So the absolute value of x is less than 1. This one, again, I'm allowed to sandwich because it is a less than. So interval notation, set builder notation would look like this. Interval notation would be from -1 to 1. Is there any questions on A or C? I'm going to erase this so that I have the space to do B. Any questions at all on A or C? Okay, so let's take a look at B. Now B is the one in which I have to do an or statement. I can't sandwich it. I am not allowed, this is a big no, to do the -7 is greater than or equal to 5x plus 3, which is greater than 7. That's a big no. Don't do that, because it's not a true statement if I pull out that middle piece. So what you can do, though, is you can write it as -7, and we're still going to have 7. Inequality is still going to be facing the same way, but what I'm not going to do is I'm not going to sandwich it. So I'm going to do it separately with an or statement, saying this or this has to hold true, or both. So then I can go ahead and do my regular algebra. So I add or subtract 3 from both sides. I'm going to work one problem at a time. So -10 is greater than 5x. When I divide by this 5, it is not negative, so I don't have to worry about, and I just wrote a negative, I don't have to worry about changing the direction of the inequality. So I get -2, x is greater than -2, and then, x is less than -2, and then I'm going to go ahead and subtract 3 over here. I'm going to do this one separately. 5x is greater than 4, divide by that positive 5, and x is greater than 4/5. Now, if I was to do a number line, here is -2, and here is 4/5, and that directly relates to these. Now, my example that I erased, the reason they switched, so if you noticed on my previous example that I erased, that I had to do this and this, they actually crossed over, and that was because of the fact that I had to divide by that negative number. But otherwise, if you don't divide by a negative number, the inequality that you are working on with the or statement should be right underneath if you were to draw the number line that it's associated to it. So the interval notation, and I find drawing a number line helps me with the interval notation, is from -infinity to -2, union between 4/5 and infinity. Now set builder notation is pretty easy. When we do set builder notation, let me do this here. So I have x such that, I didn't even do that right. So I have x such that, and then I'd write the word or, and then a curly bracket. And so this would be in set builder, and here's my answer in interval notation. Does anyone have questions on A, B, or C? Anyone have questions on A, B, or C? I do nothing all day. I teach. Okay, I teach all day until about 2. So from 7:30 to 2, I'm teaching with very little breaks in between. But I'm not really doing anything physical because I'm not moving around the classroom like I normally do. But I'm exhausted at the end of the day, more so than when I was actually teaching. Okay, now let's talk about these because these are on the homework too. We're not going to be able to get to the absolute value functions, and that's okay. We'll just pick it up tomorrow. But I do need to talk about these. So for these, let's just talk about D, E, and F. With a D, what happens with this absolute value is the absolute value has to be a positive number. So I'm not going to break this apart with an equal sign because this is equal to a negative number. That's not going to happen. So if you see something on the homework that says the absolute value is equal to a negative number, or less than or equal to a negative number, this is a no solution. So normally you'd do a 0 with a line through it, or you do empty brackets, or in web work you'd write does not exist, or no solution, or whatever it is that they're asking you to type in there. Now that's going to be true if it is less than or equal to. It's still going to be a no solution because you're asking for a distance that is a negative number. Now in this class we don't get to talk about negative distances. Maybe in your physics class you can, but you don't get to do that here. So if you have the absolute value is equal to or less than or equal to a negative number, it's a no solution. If you have this, the absolute value of 3x plus 1 divided by 3 is greater than a negative number, this is true all the time. So if you have a greater than or equal to, the absolute value is always going to be larger than a negative number. So if you have that kind on the homework, then that's always true. But with an equal sign, it is never true. So if you have an equal sign, less than or equal to, less than sign, it does not exist. There's no solution. But if you have a greater than or equal to with a negative number, it is always true. Now let me talk about E and F, and then we'll be done for today. With E, you choose the side that you want to have the absolute value taken off without any problems. So I'm going to choose the right-hand side and leave it alone. So I'm going to just rewrite this as 8 minus 2y is equal to y plus 2. Now you can convince yourself by doing it 4 times, or you just take the absolute value off one side and do it twice. In other words, do 2 things instead of 4. And you can do it. I recommend that you take the time to do all 4 of them. I'm not going to. So then I set it up as 8 minus 2y is equal to the negative of that, and 8 minus 2y is equal to the positive of that. And I work the 2. Now notice when I said the negative, I have a negative outside of those parentheses. As I take a look at F, because this is going to show up too on your homework, I am going to do like I did above, but I am not going to isolate my absolute value like I normally do because I end up with fractions, and I'm not real fond of fractions. So I'm just going to leave this x right here out front, so x minus 1 is equal to the negative of x plus 3, and x minus 1 is equal to the positive of x plus 3. And I'm actually going to do this one. We're going to work this one through. So I end up with x squared minus x is equal to negative x plus 3. And then I'm going to go ahead, and because this is a quadratic, I'm going to bring everything to one side. So I'm going to add x to both sides, and when I do that, that goes away. So I end up with x squared is equal to 3. Now I'm going to take the square root of both sides, and so I get x is equal to positive and negative the square root of 3. So that's that one. Now I'm going to come over here, and I'm going to do this one, and I've got x squared minus x is equal to x. Oop, wait. I was going too fast, even for myself. So that should be a minus 3. Minus 3. Minus 3. And when I do that, I can't, my positive to stay in the land of real numbers, I am never going to have an x squared equal to a negative number, so this part produces a no solution. That side produces a no solution, so let's go to the other side. So x plus 3. Helps if I pull the negative through. So, and then on this one, I'm going to subtract x from both sides. Subtract 3 from both sides. And I get x squared minus 2x minus 3 is equal to 0. This factors into x minus 3. X plus 1 is equal to 0. So my two solutions when x is equal to 3 and when x is equal to negative 1. So those are my two solutions. I do have to check these, however. So I'm going to go ahead and check these really fast. I'm going to put in 3. So 3, the absolute value of 3 minus 1. Does this equal the 3 plus 3? So 3, absolute value of 2 is equal to 6. 6 equals 6, so that checks. Then I'm going to do negative 1. The absolute value of negative 1 minus 1 is equal to negative 1 plus 3. I'm checking to see if that works. So negative 1, this is negative 2, is equal to 2. Does negative 2 equal 2? And the answer is no. So even though I came up with some solutions, the only true solution is 3. We call this negative 1 an extraneous solution. That's an extraneous solution. Which means we come up with a solution algebraically, but that solution does not check. So you may come across these on the homework, and if you come and you put in there 3, negative 1, it could be because one of them doesn't check. All right, so that's it for today. Thanks for hanging out just a few minutes longer than usual. Remember, we do have the e-tutoring and that quiz that is due, so the e-tutoring, but don't use e-tutoring for your quiz. See me or your fellow students. Otherwise, you all have a great day to your Thursday, and hopefully we'll get to see some sun today in beautiful, rainy Western Washington. Have a great day.